So good morning, good afternoon, good evening, depending on where you are connecting from. My name is Therese Uimana. I'm the Director of Data Evolution and Big Data at the National Institute of Statistics of Rwanda. And I work also for the Regional Hub for Big Data and Data Science for Africa. So we just provide introductions and give the floor to the experts to share with us today. So before they start, maybe for interest of those who don't know the UN Regional Hub for Big Data and Data Science for Africa, it has a mission to support African statistics offices to effectively use alternative data sources to apply appropriate data tools and techniques for providing credible and insightful statistics. So today we are hosting experts on scanner data, and the UN task team on scanner data was established back in 2017 and brings together experts from large number of statistics offices and international organizations to enable and expand practical use of alternative data sources, scanner data inclusive, into consumer price statistics. So as part of their work, the task team is interested in publishing guidance on how countries can develop their IT infrastructure to be able to incorporate these alternative data sources. So to identify good practices and inform guidance, the task team is conducting a survey on existing practices used for consumer price production systems. So because they are keeping the statistics officers as the user, so they want to understand the landscape, the context, different contexts we are in, so that it informs their planning for our benefit. So in this webinar, members of the UN task team will be available to discuss and run through the system architecture survey. So speakers today include Tanya Flower, who is Tanya Flower. I think you will more present yourself, but Tanya Flower is the chair of the UN task team on scanner data, and she's also consumer price transformation in the consumer price division. We will also hear from Colin Brown, technical advisor in the consumer price division. But please, our guests, you can also introduce yourselves in your different expertise skill set. So I think, Tanya, maybe I can give you the floor for introduction, and then Colin will take us through the details. Over to you, Tanya.
Lovely, thanks, Therese, and thank you very much for having us today. I won't spend too long on the introductions because that was a really lovely summary that you gave at the beginning anyways. But yeah, just to say hi, I will be presenting at the end of the session on the work of the task team more generally. And Colin will be focusing at the beginning on the survey slides. So without further ado, I'll hand over to Colin. Thank you.
Awesome. Yeah, thank you, Tanya and Therese, for the introduction. So yeah, I'm Colin. I'm a technical advisor at Consumer Prices Division Statistics Canada. And my colleague Steve Martin and I put together this survey on behalf of the task team on scanner data. So I think a number of the folks in attendance here probably got an email. So you'll have the emails with myself, Steve, and Tanya. So if you have any questions after the meeting, you're more than welcome to reach out to any of us. We'd be happy to clarify. So I guess before I jump in, my screen share is working, right? People can see the slides. Yeah, fantastic. Okay, so I'll go over kind of like what the presentation is going to be about, and also there'll be, of course, opportunity in the meeting to ask questions at the end. So yeah, we'll kind of cover like what the survey is about, why we're running the survey. We'll talk about some of the key concepts and sort of try or attempt to standardize some of the key concepts so that everyone can kind of have a lingua franca to talk about these systems. We'll talk about like the actual survey step by step, and then kind of what we're hoping to learn. So like what insights are we hoping to gain, and what are we hoping to share with the community? So yeah, in short, the survey is kind of about quite complicated, what you would maybe call a socio-technical system, meaning a lot of technical components, a lot of people, and a lot of interactions between those. So what more precisely that entails teams. I'll explain these concepts later in the presentation, but what we would maybe call a domain-aligned team, a centralized team, software system, so I'll talk about that as well, and then how these components relate to sort of the flow of work in a kind of data workflow, right, where you go from raw inputs all the way to some final output. And in this case, the consumer price index for our purposes. So yeah, I'll give a more precise definition of each of these terms, but the key idea is, yeah, teams own systems. Those systems and teams communicate with each other in the flow of work to turn inputs into outputs at a very high level. And in our case of consumer price index, this happens in the context of the generalized statistical business process model by the UN. So yeah, in short, yeah, basically we're trying to characterize what those team and system organizations look like. We're trying to identify a number of like tools, practices that are used to sort of fulfill the development and maintenance of those systems. We're trying to look at like what are the business outcomes we sort of care about, right? So we'll talk about that a little bit later, and then hopefully, can we make any inferences about how certain team system organizations might affect those business outcomes, obviously for the goal of improving the business outcomes. Okay, so yeah, why are we sort of running the survey? So I guess I think a lot of the folks here probably already know about alternative data, and Therese mentioned the adoption of scanner data, which is what our group focuses on. But this kind of entails a lot of different expertise across different skill domains. So like you could think like computer science, statistics, economics, and you've got kind of hard parts in each of those domains, and you got to sort of bring them all together to actually deliver these end-to-end solutions. Let's see. So yeah, and doing this development, because it requires that very distinct technical expertise, that can sometimes cut across organizational silos depending on what your organization looks like, and hence the motivation to study how teams interact as well. And the lifetime of these systems can span decades or maybe even more than a century, right, in some cases. So these are very long-lived, very complex systems. So that's true of a lot of software systems, but that's kind of unique in this case due to the nature of the problem. Oh, sorry, just a moment. And as far as I know, or as far as that we know anyway, this is kind of the first attempt in the consumer prices domain to actually try to formally characterize what these team and system interactions look like. And then also doing some of the other things I said, like identifying the tools, practices used, and characterizing business outcomes and how these things relate to business outcomes. So anyway, we'll jump into some more like concrete details about the survey now. So this section will kind of introduce some concepts, and again, like I said, trying to make sort of a lingua franca where everyone can sort of communicate the same ideas regardless of what your particular CPI system looks like. So we actually start with kind of a simplified definition of a system. So we say a system is an indivisible software component that transforms one or more data inputs into one or more data outputs. And what I mean by indivisible here is kind of like the system runs entirely or not at all. And why that's sort of important is when you're thinking about multiple systems that are sort of pieced together, an important question you can ask is like, can you modify one system without impacting another? And that has implications, of course, for how maintainable a system is. And the second thing to take note of here as well is that we're defining this intentionally very open-ended, because we realize how these systems look for different consumer prices groups could be very different depending on the organizational context. So for example, a sheet in an Excel workbook could be a system, a Java program could be a system, a Python script could be a system. So really anything on that, any software component that transforms input data to output data can be a system. And for this purpose, that lets us kind of talk about how these things can interact with each other, even if they're very different. So that's the concept of system. We're talking about, I mentioned this concept of flow of work, and in the context of consumer prices, this roughly relates to part of the general statistical business process model, I think it's called. We abstract away a number of the details to hopefully have some points that are pretty general and hopefully pretty applicable to the majority of CPI teams. So I'll go through each of those kind of high-level steps here. So the first is ingestion, and what we mean by that is getting data that's been acquired into some kind of machine readable state so that further processing can happen. And again, this can look very different depending on different organizations. That could be like ingesting a retailer's database dump into your data warehouse. That could be like entering survey data into some kind of machine readable format. Really anything that involves getting data you've acquired into a state where you can then do further processing on it. The processing itself is once you've kind of ingested the data, the idea is that you're preparing it in whatever way necessary to do your elementary index calculation. So this could be cleaning data, right? Like maybe you're imputing variables, maybe you're removing missing records, maybe there's really anything that, if you've heard the term like data cleaning, would kind of fall into this category. But the point is, it's not the actual business logic to carry out the elementary index calculation. That's obvious. That's of course the next step. And the idea here is once you've ingested and processed your data, it's in a state that's ready to do that elementary index calculation. And then this would be at whatever level of like I guess the lowest level of granularity for your price index calculation. This would be actually calculating that price movement for that, say, CPI category. After this would be the aggregation of those elementary indexes. So you can think like, for example, it differs country to country, obviously, but like you might have like, say, milk is like a low level like CPI category. You might have bread as another low level CPI category, and those would aggregate up to food, and then that would aggregate up again to like the whole consumer price index, for instance. And then we kind of have this finalization step. So storing those price indexes for future use, and then of course disseminating so you can communicate some important information about how the prices have changed over time. So yeah, those steps we're kind of mapping onto what we're calling that flow of work. So right from left to right, we have input data. We transform input data into, in our case, CPI or some kind of output, and that kind of overlays those 5 steps we talked about. So we kind of in the following order: you would ingest, then process, then calculate your indexes, then do aggregation, finalize, and release, sort of thing. So let's see. Yeah, so that's the diagram we sort of built up so far. There's, I haven't talked about it yet, and this is kind of the next slide. So teams own those systems I mentioned. And what I mean by that is a team is just a group of individuals who develop and maintain one or more of these systems. And again, we're trying to be intentionally pretty open-ended there because this could look very different depending on the kind of organization you're working at. A team could literally be one individual maintaining one system. It could be a group of 5 people maintaining several systems. It could be a group of 50 people maintaining dozens of systems. So we don't want to put any restrictions on what that could look like. The important concept is just who is the group of individuals and what systems are they maintaining is kind of the key idea there. Just a few notes. Again, we're trying to be as flexible as possible to capture as much of the organizations that we might encounter. So a system can cut across multiple of these steps. So in this example shown on the screen here, there's a system in the middle that does data processing and elementary index calculation. And what that sort of means is it wouldn't be, if you had a system that cut across those boundaries, it would not necessarily be straightforward to change just the processing part or just the elementary index part. A change to the system is kind of a thing that has to happen together, and you sort of, the interpretation there would be you'd run it entirely to go from ingested data all the way to your computed elementary indexes. And then the idea, being you can't really decouple those necessarily, as shown there. Another thing that can happen too is you can have more than one system in a GSBPM category. So it would be totally also appropriate that there's, this is what's shown with TMA in the diagram here. Maybe there's a first system, that first system passes some data to a second system, and then the output of the second system is what gets ingested and used for processing. So like a concrete example of that would be maybe one analyst has an R script, another analyst has a Python script. The R script does some of the ingestion work and then passes an intermediate file, and then the Python script does the rest of the work and then writes a file to somewhere where processing can then happen. So again, this really could be any combination of software systems. We're trying to keep it as open-ended as possible to capture as many scenarios as we can. So I made this comment about a domain-aligned team. So what I mean by that, and I'll contrast that in a second with a centralized team, but by a domain-aligned team, we mean a group of individuals who are functionally embedded, in this case, in a CBI team. So the implication there is such domain-aligned teams have a very significant CPI domain knowledge or price index domain knowledge. And why that, of course, is important is if you're building the systems for CPI production systems, it's obviously quite beneficial if the folks developing those also have that domain knowledge. But of course, that's in contrast to a centralized team. And the idea there is you have a group of individuals who are centralized somewhere else in the organization, not part of the business domain. And the idea there is those teams tend to not have that domain knowledge. So an example of this would be in, say, a large organization, you maybe have a corporate IT group, and the corporate IT group kind of by definition isn't embedded in any one particular domain. Rather, they're sort of central to the organization. So if you need their services, let's say, to develop something, to fix something, to participate in the maintenance of those systems in some way, you need to transmit your requirements or communicate your requirements to them because they're not going to have that domain knowledge. So I use the light orange color here to indicate the domain aligned team, and then the blue color to indicate centralized team. So that'll, if you see that in later diagrams, that's what it's referring to. Okay, so we talked about a lot of these diagram components. So kind of what's the point of that, and what are we trying to achieve with that? So what the point of all of these components are is our attempt to sort of have a universal way through diagrams to sort of describe and characterize your CPI system. So this is what I'm about to show now is an example of what this could look like for an organization. Everyone's organization is going to look different, but it's just meant to kind of put into practice and hopefully anchor it to something concrete. So in the next few slides, I'll kind of go through each part, like ingestion, processing elementary aggregate or elementary indexes, aggregation, finalization, and how these relate to the concepts we just discussed. So this first part, what this would kind of depict is that there's one system maintained by a team of, let's say, economists or statisticians, and that one system ingests a particular input and then it produces that for downstream data processing. And then the remainder of inputs are ingested by one system maintained by a central corporate IT team. They ingest those inputs and then make them available to the processing step. So two different teams maintaining two different systems, one quite large system, one quite small system. The next thing that would happen is those ingested data become the inputs to sort of the next step. So the top team here is shown by another team of, say, economists, statisticians. They maintain one system that cuts across processing and elementary indexes. And the idea there is, again, like I said before, you can't really decouple the components of that. The system runs entirely and it does all the processing and elementary index calculation in one shot and produces something ready to go to aggregation. The remaining teams maintain two different systems that are decoupled. So the idea here would be you'd have these three systems where my cursor is. The first one would do just the processing. It would pass an output to another system that did just index calculation. So you could go in and make a significant change to one of these systems without affecting the other in any meaningful way. Oh yeah, I already mentioned that. No, okay, awesome. And then the final step, this sort of shows one large system maintained by one corporate IT team, and then this system does both aggregation and finalization. So again, the idea there is it's not straightforward to make a change to just the aggregation part without also needing to consider the impacts on the finalization part. And then the idea is that that system would aggregate all the way up to the CPI, and the final output it would produce, of course, is the CPI. Okay, so concluding thoughts on the diagram. Again, what I've alluded to a few times, the goal here is to kind of have a lingua franca so that everyone who works on CPI systems can express these concepts in hopefully not too complicated diagrams. And again, this is largely because there's so much variation in what these systems could look like. We tried to really boil it down to just the key components that are hopefully common to the majority of statistics organizations. And the other thing I'll flag too is our goal is with this survey is it's absolutely not to create an exact replica of your CPI system. We're just trying to roughly characterize the like key important aspects of that system. So don't as you're answering these questions, don't worry if you're not able to like fully completely characterize your system. What's important is that the key details are captured in this diagram. Okay, so then this is the second to final part of the presentation. We're just going to go through at a very high level each of the 11 pages of the survey that I believe most of you were sent. So we'll kind of go through one by one and talk about the key pieces. So the first page is about what we're calling system boundaries. So you might recall as I was presenting the previous section, I made comments about like, are the systems decoupled? Are they coupled together across 2 or more GSBPM steps? This question is kind of about that. We're trying to understand how many systems are in each of those categories and how many occurrences are there where a system can cut across those boundaries. So there's 2 kind of extremes here, and the vast majority of organizations are probably not going to be either of these. They're going to be somewhere in the middle. One extreme would be a perfectly modular setup where every input has its own system that can be maintained in isolation from everything else, and every step has its own system dedicated to each input or group of inputs or something like that. And then the implication here would be any one of those systems could be maintained and changed in isolation without affecting the others. Again, probably most organizations don't have something that looks like that. That's kind of a far extreme on one side. The other extreme, again, most organizations probably also don't look like this, but the other extreme would sort of be you have one system and one team that handles absolutely everything and just produces the CPI. So again, that's the characterization of those is to try to, it's a spectrum, right? So we're trying to understand on what end of the spectrum do teams sort of fall, and most are going to be somewhere in the middle. But that's kind of the point of that question. So the second question, we're talking about team boundaries. So we talked about systems initially, and then we talked about teams as groups of individuals who own those systems. So on this page, we're trying to understand what kinds of teams are involved in each step, and again, if they cut across those boundaries in any meaningful way. So again, it's kind of hard to standardize this across all the organizations, so we tried our best to make some generic categories. I'll explain them here. So we have a category called corporate IT, and the idea is this is basically just information technology professionals who are part of an organization-wide central group. So again, the key concept there is IT professionals have background in, computer science, software engineering, IT, something like that, who are not part of the domain. And that's in contrast to domain embedded IT, which is similar IT professionals, similar background, similar training, but these individuals are actually part of the CPI domain team. So they're not centralized, they do have that domain knowledge. The third one is what we're calling domain embedded analysts. Again, kind of hard to characterize, but this is basically professionals who don't have a formal IT background. So an example would be like economists, statisticians, mathematicians, basically any person who's doing like analytical work on the CPI, who's functionally embedded on the CPI team. And just to note here, this doesn't imply that these individuals aren't technical or don't have technical skills. It's just they're not formally classified as IT. So you could have technically savvy domain embedded analysts who are just not, don't have an IT background. And then we also have what we're calling elsewhere analysts or analysts elsewhere in the organization. This is kind of meant to be a catch-all category for anyone who's not an IT professional and not a domain embedded analyst, but still does some kind of maintenance or development on the system. So the idea here, just formally, it's people who don't have formal IT training who are not embedded in the domain team. So again, if there's anything that doesn't fit into the first 3, you can use the fourth as sort of a catch-all to capture that. And then there's the fifth option too, distinct from the rest, which is anyone you've contracted, like a consultant or a contractor outside the organization. So for example, if a consultant or a team of consultants or contractors was hired to develop part of your system and perhaps maintain it, that would be its own category here as well. Okay, so the third question, this is probably the trickiest of all the questions in the survey. So I'll try to explain what we're trying to learn here, and hopefully it's not too complicated. The first 2 questions kind of looked at each piece in isolation, right? Like, what is the system, systems, and how do they cut across system boundaries on its own? Teams, and how do teams participate in the GSBPM workflow on their own? But of course, what would be very interesting is if you could jointly say, how does your team and system organization look together? So this is what we're trying to learn in this question. Obviously, that's a very hard thing to characterize in a survey, so we're trying to add some simplifying assumptions to make it not quite as difficult. So we introduced this concept of a representative group of systems, and the next slide, I'll have a diagram of what that looks like here. And the idea is basically we want to, instead of saying like, think about every system and every team involved, think about like a team that represents an important part of that workflow. So like what's the key patterns behind that? And I'll walk through an example in a second. But yeah, I already talked about that. It's not feasible to characterize the whole joint system team topology. And the other thing I just want to flag here is throughout the rest of the presentation, I'm going to use the term the typical flow of work, the typical team, the typical, and what I mean by that is just representative, right? So the important thing is to not overthink it. Just think, what is a typical example of the thing, and it'll probably come to mind. You'll go, oh yeah, I have a sense of what that is. That's what we're looking for here. So it's kind of an informal definition, but you'll see me use the word typical throughout, and that's kind of what I mean. So anyway, this example here, we're kind of showing there's this red dotted line around a subset of that system diagram, and the idea here is it's a group of systems that represent an important share of the CPI calculation, and there's subsets of these that behave in a similar way. So an example of what I mean by that would be like there's an ingestion step done by that one system with that one corporate IT team. In this case, there's 3 systems, but they all behave the same way, right? There's a processing system, there's an elementary index system, they're owned by an economics and statistics team. And even though there's 3 of them, that doesn't really matter. There could be 3, there could be 5, there could be 10, but they all behave in the same way. So we called that, we introduced the term system group to describe that. And the idea here is we're trying to characterize a pattern, not a specific instance, so to speak. So we would sort of say, okay, the first system group is this corporate IT team maintaining that one system. The second system group is there are some number of systems that have a processing system that is decoupled from the elementary index system, and those are owned by a domain team. And then there's a third system group that is, in this case, just a single system that is maintained by a corporate IT team. So again, the survey itself has a much more elaborated explanation that hopefully is a bit more clear. Like I said at the beginning too, all of our email information was sent out with the survey. So if anything is unclear, you'd like any clarification, please don't hesitate to email myself, Steve, or Tanya. We're more than happy to help out. Okay, so takeaway of this question, the reason we're basically asking this question is we're trying to understand which teams maintain which kinds of systems. So we're trying to, jointly answer that question, where in page 1 and page 2, we're asking about them independent of each other. So then the idea of doing the representative group and the idea that there's system groups within that representative group is we're just trying to characterize a subset of your whole CPI production system that kind of behaves the same way. And then that way we can kind of talk about one thing when we're asking questions about like who maintains it, what boundaries do they cut across, and then that lets you kind of ask that joint question with just a single example rather than trying to characterize both of those things for every system in your organization. So yeah, it's kind of a complicated concept. I hope that's clear. But yeah, like I said, please feel free to ask questions if anything about that is unclear. Okay, so the rest of the survey is a bit less complicated. Page 4 is pretty straightforward. It's just what tools, technologies are in use in the creation, development, and maintenance of these systems. Obviously, more elaboration in the survey, but that's the high level. Page 5 is about the age of the system and the update frequency of your systems. So again, I also use the word majority and typical here. Again, the idea is all of these questions, we're trying to characterize the distribution of characteristics, but obviously that's impossible and would be extremely burdensome to ask respondents to do that. So we're trying to collapse that into just like one data point, right? So when we're asking about this question, we say like, thinking about the majority of your systems, approximately how frequently are they updated? And the same advice I'd sort of give here is don't overthink it. When you read that question, I think a lot of the folks here, you probably go like, oh yeah, I have an idea of what that means. I know what most of my systems behave like. That's really what we're going for here, trying to get that high level characterization. And I'll also flag here, and this is similar for a lot of the questions, we introduced bucketed responses. So we're not looking for anyone to be like, oh, our systems on average are updated every 3 months, 2 weeks, and 4 days or something. What we're more looking for is like, is it every month? Is it every quarter? Is it a half, 2 times per year? This is the level of granularity we're looking for. So the buckets kind of reflect that. So again, no need to have like a super precise idea, just a high level idea is what we're looking for. So the sixth page is about the number of individuals required to implement what we're calling small changes and large changes. And the survey will explain in more detail what that means. And again, for this question, we're thinking about the typical system. So for the typical system, how many individuals usually need to be involved? So, or more precisely, for the typical system, on average, how many individuals need to be involved with a small change and a large change? And again, the survey includes some examples to hopefully make that question a bit clear. So this seventh page is about obstacles and challenges for alternative data adoption. So what we're trying to characterize here is what you maybe call the implementation gap of alternative data adoption for CPI production. And what we're kind of going for here is basically, are a lot of organizations facing similar challenges? And if they are, then that will give us a good idea of where we can provide guidance and help to address those challenges. Page 8 talks about how long changes takes. So again, we're thinking about like, I want to make a change to a system. How long does it take to go from the initiation of that to like that change is in production and live in use? And again, we talk about this for small changes and for large changes. The survey explains in more detail what we mean by that. And again, like before, we're talking about this for the typical system. So for the typical system, how long on average do these changes take? And again, they're bucketed responses. So we're not looking for they take 7 days, 4 hours. Like we're just looking for like, is it like within a day? Is it within a week? Is it within 2 weeks? So the responses will reflect that coarse-grained nature. Page 9 is about general challenges facing CPI teams, more generally. So we're trying to, just regardless of alternative data or not, we're trying to just understand what are the key challenges in the development and maintenance of these systems. Same idea, if a bunch of organizations are facing common challenges, then we can provide guidance to address those most important challenges that many organizations face. Page 10 and 11 are kind of the last part of the survey. Page 10 is just a plain text field where you can provide any feedback about the survey. I think it's quite general, just feedback of any kind, anything that wasn't included in the questions. We'll personally read all of these. There's only like 200 instances of the survey, so we will personally go through, read them, and acknowledge anything you read there. So please feel free to provide any feedback you like. And page 11 is independent from the rest of the survey. It's about the task team more generally, which Tanya will present about after me. And it's just to provide feedback on the task team for scanner data more generally. So there's a number of questions there related to the task team scanner data, how we could improve it, what is most useful, these kind of things. Okay, so then just to kind of conclude, what we hope to learn, there's kind of 4 things in the following level of feasibility. So the thing we're definitely going to do is we can provide a lot of descriptive statistics to kind of characterize the state of these CPI systems in 2025. To the best of our knowledge, this hasn't really been done before, so hopefully even basic stuff like this is on average how long it takes teams to make changes, or this is the kind of tools and technology that are used for each of the GSPPM steps, like simple stuff like that. We're hoping even that will be hopefully quite informative. The second thing we're hoping to do is create what we're calling archetypes for organizations that have have traits in common. So like, for example, there might be one archetype that would be like, say, relatively small countries maybe have quite a small team and their system organization is maybe a bit more centralized, whereas maybe larger countries maybe have multiple teams and they have like a central IT team or something like that. Maybe there's a third that are organized around open source tooling, and those look quite different from those that are organized around enterprise tooling. So we're not quite sure what we'll find yet. Part of the analysis will be figuring out what those clusters or groups look like. But what we're hoping to do is define, are there any such archetypes for common characteristics? If there are, we're hoping to correlate those with some of those business outcomes we talked about earlier in the survey. And then obviously this correlation, not causation, but can we make an educated guess about how certain characteristics might relate to those business outcomes. And again, the big caveat there, obviously, we're not making any causal inferences. Let's say we're more hypothesizing how, based on industry knowledge from other areas like software engineering, can we make an educated guess about how some of these archetypes and characteristics could lead to improved business outcomes. So anyway, that is the end of my presentation. Thank you all very much for listening. I'd be happy to, we can either take questions at the end, or if Tanya wants to present, and then we take questions for both at the end, whatever is preferred.
Thanks,
so it's maybe
Colin.
a question. Yeah, no problem. Go ahead, Tanya.
Yeah, I think maybe if we do 10 minutes of questions now. I think my slides, so Colin can send around the link to his slides, and mine's a PowerPoint. So a lot of the information, like you can just read after this session. So I think it's more helpful if there's questions to focus on now, or you've got lots of rounds of applause coming in.
Thank you so much, and that sounds great. I'll put the link to the presentation in the chat as well. So it's I will send it out later. But yes, Tanya said you'll all be able to see it. But yes, absolutely happy to take any questions. Puina, my apologies if I'm not pronouncing that correctly, but please go ahead. Tapua, or Jeremiah? I'm sorry, Jeremiah, I believe, has a question. Go ahead. Oh, you're on mute if you're talking.
I don't know if we need to. I think I've unmuted you. I'm not sure if there's anything. I don't know if Teresa's still on the call. Jonas, is there anything that we need to do to allow people to ask their questions?
Yeah, now the mic is on. They can use their mic. So I think.
Got it. Yeah, so I see one hand up from Jeremiah, I believe. Yeah, sorry, Jonas, go ahead.
Jeremiah, you can ask your question now. You can unmute your mic and you can ask.
Apparently he still has issues because he's texting that he needs someone to help him. Jeremiah, in the meantime, you can text in the chat while maybe Jonas is looking into helping you out.
Okay, I think I managed.
Okay.
Okay, thank you, everyone.
Yes, we can hear you.
Good afternoon, evening, wherever you're finding yourself. My name is Dapewa. Jeremiah is my surname. I'm a CPI statistician from Namibia. Well, thank you for the presentation, even though it was really fast, we couldn't catch up with everything. So I just want to make sure that we are on the same page when we are talking about, when you're asking information about these systems. Is it just the system that is generally for CPI that we use now, or for just specifically for scanner data? Because at the moment, we don't have a scanner data system. But if I to look at the system, or what we call system in Namibia to produce CPI, I can relate to your graph. By then, that's if you can accept flat files, the Excel flat files as systems, because everything we have is in Excel files.
Yes, no, good question. Absolutely. This is not specific to scanner data. Any system you use to calculate your CPI is in scope. So what you described would totally, everything there is in scope. And for the system, it totally could be like, if it's a series of Excel workbooks, that absolutely counts as a system. So yes, what you described is in scope.
Okay, so now let me give you an example of what we have. We have the ingestion part where we have a team of data collector. They are the one that get the data from the prices from the shelves and then enter them on the tabs, enter the data on the tabs and send to the second team what we have as assistant statistician that do the verification and processing and then the statistician just do the elementary aggregation, and of course, a verification as well at some point, and finalization. Will that be will that be like a 3 system like that, or it's just one system?
No, that sounds about right. Yeah. So basically, where the boundary. So in your example, the boundary might be where you have, say, different Excel workbooks, for example. So if I'm understanding you correctly, you have a data collection step where you go into, say, the store, calculate the price, or take note of the price, the product. You maybe enter that into, say, an Excel workbook, for example, and then another person, like say another team, does, as you said, like validation, index calculation. So if those are, say, 2 separate Excel workbooks, there would be a system boundary there. And if it's 2 different teams, which it sounds like is what you said, there would be 2 different teams there. So you'd have like team A would be the part who does the collection and taking note of those prices. And team B would maybe be the statistician you mentioned, who does the validation and cleaning, and perhaps the index calculation and so forth. Does that answer your question?
Okay, then if you have, let's say, 10 data collectors from different localities, and they each enter prices on their tabs, do you count that as 10 systems?
Yeah. So what you could do there is you could have 10 systems with 1 team. So each system would be like that collector's, say, device. They're entering their data, and it sounds like from what you said, there's 10 such devices. So you'd put 10 systems there, but those could all be, if I'm understanding you right, part of the same team, like say data collection team. Yeah, does that make sense?
Yeah, it does. And the second question is that when you're saying updating frequency, do you mean like, let's say, to renew the system or according to version, or even adding data to the system counts as update?
Yeah, good question. The survey itself will explain more details of what we specifically mean by that. But at a high level, we're basically talking about any what we would call a non-trivial update. So the latter example you said of adding a data source, that would be considered like a pretty important update, or I think we would call that a large update. So yes, for those. What we're more sort of talking about would be so trivial updates would be like, let's do your work computer. Maybe your IT department says, hey, we're upgrading you to this version of Windows 10 or something, but that has no impact on like how you do your CPI calculation, your methodology, your like nothing about your CPI system changes. That's just the kind of in the background update, let's say. What we want to exclude those because they're not really related to the system. But yeah, anything that's an important update to the system itself, like the examples you said. That would be included, and that would be considered probably a large
Like,
update.
for example, in our case, let's say formulas.
Yes, that would absolutely count. Yeah, like if you made a change to your price index formula, that would definitely count.
All right, thank you.
Absolutely. Isafu, if I'm pronouncing that correctly.
Yes, it's Isufu. Good afternoon. So it looks very interesting. I'm from UNECA also, so I'm seeing a good opportunity here. But what I am seeing is that the language is a little far from what we are used to as statisticians. I think it's more systems language here. So I'm wondering if this questionnaire you have already piloted it. Did you make some kind of pilot test with some organization, including in Africa, to see how people understand it and what would be the quality of what you are receiving as answer? Or it's now that you are trying to test it for the first time?
Yeah, no, it's very, very good question. Yeah, we did do a little bit of piloting, but unfortunately we didn't have the opportunity to do that at the scale you're describing of different countries around the world. It's very totally valid point. This is so yeah. My background's in software engineering and computer science, but of course this is very like we kind of said, interdisciplinary. So the attempt I tried to go for here is hopefully using either language that's common to the vocabulary of folks doing statistics, economics, or at the very least, hopefully not overly technical or verbose. So my apologies if any of the terminology is unclear. I guess the two things I would sort of say here is this survey, if it is launched again, like a year or 2 years from now, we'll very much revise it in light of feedback. So I guess to Sofu's comment, like if there's if you're finding any of the language is unclear, maybe if any terms are unfamiliar, please let us know either in that feedback box in the survey or just email us directly, and we'll definitely take that into account. The second thing is for this iteration in particular is final just for time constraints. But if anything's unclear while you're answering the survey this year, again, please feel free to send an email to myself, Tanya, Steve. We'd be more than happy to help clarify any of the terms.
Yeah, one of the things that we want to do in this space is try and harmonize terminology, and the handbook that I'll talk through in my slides, there is a starting point of a glossary on there that we're trying to expand, but doesn't have much in it at the moment. So any feedback would be really helpful in this space, and to clarify what we mean in here. Yeah, we did run it with we've had people from the World Bank and IMF review this as well, but there's only so much we can get with the feedback. So we just had to go live with it in the end. But yeah, really grateful for any feedback on any of that specific stuff.
Yep, absolutely. I don't see any other hands up for questions. So in light of time, maybe I'll propose, Tanya, if you want to do your presentation now. Awesome. Thank you so much, everybody, for the questions and for listening.
Yeah, thanks, Colin. So hopefully you can see my...
Yep, clear on my side.
Yeah. So yeah, just aware a bit of time, so I won't go through all my slides that I've got, and I will just send around a link at the end of this session, so you can have a read through at your leisure. But just to give a bit of a background around the UN task team and our work. So we're part of a wider group on the UN big data side. So there's other task teams you may be aware of, for example, on mobile phone data, Earth observation data. I've included a link there. All those task teams have a very similar kind of mandate in terms of developing methods guidance for these new data sources, and developing code supporting that guidance and training as well. So the task team on scanner data, I think Therese said in the introduction, we've been around since 2017. We've done various pieces of work over that time frame. Last year we had a bit of a refresh and wanted to kind of set ourselves up for the next 2-3 year period. So we've updated our objectives and some kind of underlying principles that we use in our work as well. So we want to make sure that this content that we produce is maintained over time, still useful, and we're not here to provide a kind of single best approach. As Colin says, there's lots of different scenarios and lots of different organizations across the world, so it's more to say, look, these are the different options, here's some guidance around that, and then for everyone to make up their own minds about where to take that. So those are the underlying principles for our objectives, and then our objectives again are more around providing guidance material, acting as that repository of information for users, and providing advice on the practical implementation of these new data sources as well in a production setting, and training as well as part of the task team work. So we've got a few work streams in progress at the moment. I think I'll just flag specifically the handbook work stream, which is probably going to be the most interest to everyone on the call. So this handbook has been developed and published last year with the idea that it has information from how you acquire these new data sources all the way to preparing the data, creating indices, and then how you implement in the kind of final production system. So it is a work in progress. There are still areas, for example, in classification where we are still developing the guidance, but we will be maintaining and updating that over time. So keep an eye out on that link. That's included in the slides there. And then yeah, just have a flick through these slides when I send them around. There might be some bits of interest there. We've talked about the system architecture work stream, so that's what we're doing at the moment. And this survey is one of the deliverables for that work stream. Just to flag the task team questions at the end of the survey, Colin, I think it was like page 9 or 10.
Page 11, I believe.
Page 11. There we go. So they would be really helpful to get your feedback on areas, topics that would be helpful to focus on, kind of priorities, that kind of thing, to assist us in the longer term planning. And also, if you are interested in joining any of the task team work streams, for example, the training work stream is quite active at the moment in developing a lot of the supporting material. We've obviously got quite a lot to do on Colin's side to review these survey responses and provide the guidance. So if anyone is interested in supporting the work there, very happy for you to get in touch. I've put in a list of contacts for each of the work streams there if interested. But yeah, those are the main things. I won't go through the whole slide pack, but I will send that round. So please do get in touch if you've got any questions. But that's it for today. I think we've got 1 minute left, so if there's any immediate questions, I can take 1 or 2, but if not, I will send around the content. All right, well, I think we've got to the time anyway, so yeah, big thanks to everyone for attending. Hope you found that useful. And if you haven't received that survey link, please do get in touch and we can email you that directly. You'll need a specific link to access that survey. And we really look forward to seeing all your results. I think it'll be really interesting, and we will aim to publish these results. Oh, that was one thing to probably highlight. It's the kind of April 2025 we want to start processing and publishing these results, so keep an eye out for those. We might do another webinar. We might come back and present those results if that would be of interest to you guys. So yeah, okay.
Thank you, Tanya. Thank you, Colin, for a good presentation. And maybe before we close, if maybe you can share in the chat the link to the handbook. I wanted to do so, but I couldn't text. I don't know, maybe I'm using the desktop version. So if you can share the link for participants to go through and familiarize with scanner data and tools that are available on your page. So
oh, I can't post in the chat either. I just tried. I'll send it around with the slide pack.
Okay.
Okay. Thank you.
Okay, Jonas, I've shared to you the link. If you have possibility to share in the chat, please do. So thank you, and thank you all the participants who managed. I understand some of us are ahead and it's night where we are, so thank you for your valuable time. I thought you had some information on the task team on scanner data, and please do read on their page more of what they do. And we are having upcoming webinars. We will share information very soon. There's an upcoming webinar around use of updated package on R for civil registration. So we are sharing more details very soon, and we hope to see you again. Thank you, everyone. Bye.
Thanks so much. Take care. Bye.
Thanks.
Thank you,
Amy.
Teresa. Please also fill the webinar evaluation form. I just share it on the chat.
Bye, everyone.
Thanks.
Okay,
Bye.
thank you. Bye.
Okay, thank you.
Thank you. Bye, everyone.
Bye.